Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to first of all thank Pivotal for sponsoring today's event. Pivotal is a wonderful partner and supporter of the Data Science Central community, and we are honored to have them sponsoring today's event. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Tableau, LavaStorm, TIBCO Spotfire, Hortonworks, and Splunk, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to do so, as they do provide some very useful information. Today's webinar is entitled Big Data Science. And before we begin, I'd like to just briefly review our format for today's webinar. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a moment. We should have about 15 minutes for Q&A following the presentation. And this webinar is being taped and will be available on demand sometime tomorrow at datasciencecentral.com. I would also like to encourage our attendees to provide questions directly to me throughout the presentation. I will be reviewing them and presenting them on your behalf with the time remaining. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce today's moderator, Dave Menninger of Pivotal. Dave is the head of business development and strategy for Pivotal. He has also worked as VP and research director for Ventana Research with stints at Vertica Systems, Oracle, Applix, InfoSense, and IRI Software. Joining us also are our two panelists, Bill Jacobs and Stephen Hillian. Bill is the Director of Product Marketing and brings a unique perspective on big data analytics, having worked with big data pioneers in telecom, financial services, health and science, retail, and manufacturing for the past 10 years. He is currently leading efforts to help our users and IT teams realize the value of big data analytics by making their analytics faster, more scalable, more portable, and easier to use throughout the analytics and model development lifecycle. Stephen has been leading large engineering and analytics projects for 15 years. He founded the analytics group at Greenplum, leading a team of data scientists and also designing and developing new open source and enterprise analytics software. He received his PhD in mathematics from the University of California, Berkeley, and was a King Charles I scholar at Oxford University. So welcome to you all. I appreciate you all spending the time with us today. And so in today's webinar, we're going to be discussing that big data requires a different approach to analytics, requiring different skill sets and different tools in order to maximize its inherent value. Today you will learn how data science differs from business intelligence and how your organization can take advantage of technology designed to deliver predictive analytics and data science over big data. So with that, I'm going to pass the baton over to you, Dave, and you can begin your presentation.
Thanks, Tim. Well, first of all, I want to thank you and the audience for the opportunity to speak with the Data Science Central community. I think this presentation today is directly on topic to the nature of the community, talking about data science. And I want to give a brief introduction to Pivotal so you understand why we're sponsoring this event and why we think that data science is a critical element for successful deployments involving big data. So Pivotal was formed at the beginning of April, and it's led by Paul Moritz, our CEO, who is the former CEO of VMware. And we're focused on delivering platform-as-a-service capabilities to the enterprise. The notion of these applications that involve big data and deploying them on hundreds or even thousands of nodes requires a new approach to how you might deliver and deploy those applications and how you might work with the data in those applications. And so, that's part of the interest that we have in participating in today's event. The organization, Pivotal, was formed from a number of assets that exist in the market already. We have a number of products. Although we're in some ways a startup, we're a well-established business as well. We're combining the products from the Greenplum division of EMC, along with some of the VMware products that are listed on the screen here, to be able to deliver a platform as a service capability that can provide big data analytics as well as be able to do that in a cloud-independent way. We believe that applications are a critical part of this story, and those applications will typically involve some of the types of analytics that we're going to talk about today. When we talk about the portfolio of assets and how they fit together, we typically talk about 3 layers or 3 fabrics of our platform, which will be called Pivotal One. It's the cloud fabric, the data fabric, and the application fabric. And so we deliver these capabilities, and we're working on integrating those assets that I mentioned on the previous slide. We deliver those capabilities today as independent products, and we're integrating those products into a single common platform called Pivotal One. We previously announced that that platform will be available at the end of this calendar year. And in delivering those capabilities, we often spend a lot of time working with customers, particularly in the area of data science services, offering things that we call data science labs, which are listed on the screen here. And those do require a different approach, a different set of skills, a different way of analyzing information that many of the customers I meet with are not necessarily familiar with or don't necessarily have the skill sets available to do those types of analyses. So my hope is in today's event that you'll begin to develop an appreciation for what those types of analyses are, why they're important, and why in the context of big data especially, those types of analyses are even more important. Now, today's presentation is really about our partner ecosystem and how they support the data fabric elements in particular of our Pivotal One platform. The platform that we're putting together is an open platform, and we've developed a number of partners as part of our ecosystem. And this is one of several webinars where we're educating the market on what our partner capabilities are, who those partners are, and how they can help you take advantage of the big data systems that you may be creating. And so with that, you can learn more information about Pivotal. Again, that's not really the focus of today's presentation. Today's presentation is really about our partners. You can learn more about Pivotal at gopivotal.com or follow us on Twitter at gopivotal. At this point, I'd like to turn it over to Bill Jacobs of Revolution Analytics to tell you about their work in the data science space. Bill?
All right. Good morning, and thank you, Dave. Thank you all for taking the time to give us a listen here. I hope you find what we have to say useful. I'm going to hope that I'm looking for control of the screen now here.
Yeah, you know what? For some reason,
I will.
bear with us, everybody. We're having a little bit of an issue.
There.
So it shows that you're offline.
Okay, show my screen. Can you see my screen now? I'm seeing it here.
Yes.
Okay, perfect.
Very good, very good. Well, let me just start by saying I'm going to take a kind of a product-centric spin at this for just a moment, and the reason is that there are a lot of different ways to approach big data analytics, but there's a couple of very specific problems that Dave's already hinted at, and I think we'll all talk to, that revolve around the talent pool issue for big data analytics. Anytime we observe a major shift in the technology industry, and as you can see from my picture, I've got a little gray hair and seen a few of these transitions before, there is at the beginning of each major shift in technology typically a scurry, if you will, and a scramble on the part of CIOs, on the part of end-user organizations to acquire the required talent. So I'm going to talk a little bit about what Revolution Analytics does, what we provide in that talent problem, a little bit about our products, and then we'll turn it over to Stephen from Alpine Data Labs. My particular bent on this is interesting. You know, I've worked in a number of companies where big data was the target well before we started calling it that. I wish I'd minted the phrase big data and was earning a penny or two every time somebody uttered it. But it is true, as Dave said, that it fundamentally changes the way that we have to deal with data. And the way that we observe that as a provider of tools for creating big data analytics solutions is that historically, many of the analysts that work in statistics and mathematical analysis have been able to work in pockets, oftentimes independently, oftentimes kind of distant from IT. The fundamental shift that occurs with big data is we're now typically as organizations dealing with data assets that are sufficiently large. It's simply no longer possible or pragmatic to try and isolate that work. The volume of data required, the computational complexity of what we're trying to do with that data. Once we conquer the ability to grab the data and act upon it and learn from it in those first two blocks, the next major challenge is how do we assure that those solutions are enterprise ready? Much of what's going on in the industry is around Hadoop, for example. We all know that the early days of Hadoop were fraught with headcount rises among those companies that were embracing it. The household names in the data science business around Silicon Valley, the LinkedIn's and the Yahoos that in Google that in some ways invented Hadoop, did so by hiring armies of administrators and programmers to build those platforms and to keep them alive. That model no longer works as we go out into corporate IT and we try and deploy these as 24/7 assets. And finally, hopefully the big data challenge that we all deliver upon is really working to accelerate the innovation or to provide agility, if you will, to the analytic processes, because one thing we do know from historic analytic activities is that whatever you invent today is probably obsolete tomorrow, if not, sometime later this afternoon. So there's a lot of changes that no longer reflect the way we did analytics in the past. But going back to the fundamental issue, we think the biggest issue of all is the analytics talent pool challenge. I was speaking with an analyst from one of the major firms, a household name, just last week, and he explained to me a conversation with a CIO who described hiring a data scientist recently as an exercise in blood money. I believe the quote I heard was something along the lines of, I have never had to pay that amount of blood money to hire a data scientist. And I think this underlies this is the manifestation of the talent pool problem, that if you can hire these people, they're very expensive and very likely, if they're at all dissatisfied, to be receiving offers from other firms and have fairly short tenures. Our perspective as a company is that there is a very large community accessible to corporations that already know a language called R. I'm going to tell you a little bit more about that. Many of you may already be quite familiar with it. But fundamentally, by our estimation, the open source analytics language known as R is in use by perhaps as great as 2 million people worldwide. Many solving small problems in corners and niches, but increasingly an increasing percentage of those users are being drawn into big data challenges. It's our company's role to help people use R in the context of big data. We believe the open source editions work great for modest-sized problems, but they break down in big data, and I'll get to some of those reasons. So what is R? People think of R as a language. It is open source. It was built specifically for providing a language that statisticians, mathematicians, and other data scientist types can use easily. It is also not only a language, but a complete data visualization framework. But I think that is very much selling R short to describe it as a platform. In fact, the greater implications of R are this 2 million user community and the user groups that exist across the world. We're seeing a rapid increase in the number of academic programs that utilize R as a teaching tool and are therefore minting new potential employees for your organizations at very modest cost when compared to your typical experienced data scientists. And we think this is the way that R will fundamentally change the nature of the talent pool problem. A third element of R that is always worth some investigation is that it is a huge sharing community. By our count, the community repository of algorithms for R, known as CRAN, currently contains greater than 4,500 algorithms, many of them with test data and evaluation write-ups and that sort of thing. Some fraction of those are applicable to big data, not all are, and I'll tell you a little bit more about that next. So where does Revolution Analytics come into this? R is a very effective language when used for what it was designed for. But as many of you may know from using the open source versions of R, it is single-threaded and memory bound and tends to exhaust the memory in the machine it's on reasonably quickly. While it's very much a rich language of capability, data handling designed to deal with problems like missing values and tabular data formats like in something called data frames, it basically runs out of gas in big data over the ability to manage data greater than the size of the machine it's running on. So Revolution Analytics was founded, I believe it was 6 years ago, with the intent of taking R further down the track, if you will, to solve big data problems by endowing it with transparent ability to handle large amounts of data and to scale out the computation built using the R language to run on a variety of parallel architectures and allow, in effect, transparent, independent scaling of those applications once they're built. As we've moved into that business, we have grown beyond R itself to not only enhance R's capabilities, but also to provide the ability for customers to receive commercial quality support. We have at times have been described as the red hat of R, although I think that's a fairly short-sighted definition. And then we have grown to provide the ability to take the most popular of the algorithms used in statistics and mathematics around big data and parallelize those algorithms by refactoring them such they provide orders and orders of magnitude performance improvement.
Hey, Bill, it's Tim. I'm sorry to interrupt. It looks like your screen may not be, maybe somewhat offline. Are you able to check your settings just to make sure? I don't.
Take a look here.
I don't think your presentation doesn't look like it's quite.
Start again here. See if we can get an update.
On my control panel, it's showing that you're offline, so I don't know if there's a connection issue.
Yeah, let me double check.
You.
Yeah, we'll have to do something fairly creative if that doesn't repair itself.
Okay, and audience, I appreciate your patience. Sometimes these things happen, but I'm sure this will be resolved fairly quickly.
Okay, I show myself as on air. Tim, what do you see?
Okay, yep, you look like you're back on air, so there you go. It's working again.
Okay, very good. Well, I'm going to back up one slide then. I know that there was a graphic there that I think people probably needed to see, and that was this one. To review again what I said a moment ago, R is a well-designed and useful language for stats and math, but memory-bound and single-threaded, and we set about fixing those things to enable R to be used in a big data context on a variety of highly parallel architectures. Skipping past our wherewithal and what we do, this is a view of our platform, and I only want to put this up for just a moment, simply to point out that only the bottom block is the open source contribution of R. We add many other capabilities to R to enable it to run in a big data context. But starting from the bottom up, RevoR is essentially open source, the open source version of R with a number of enhancements to enable performance and ports of that to run on a number of platforms everywhere from workstations to clustered servers such as Microsoft HPC, some of the various MPP databases, and we have a very strong program going to bring more and more of our capabilities to Hadoop. Above that are a number of other capabilities that give us the ability to run at very high speed in parallel environments. Those are the ScaleR and DistributedR blocks, which I'll touch on in a moment. Connectors to external data sources, and these are critically important because this is how we interact with the platforms from Pivotal. both the Greenplum database and Pivotal HD. We will talk over time in coming months about some enhancements there. And then, as I mentioned, making R easier to use, we provide an IDE I'll show you a picture of. That's the upper right block. And we provide the ability to write R programs and to use R to display data, but also to then enable those R analytics models to be deployed into the organization, typically via web services, so they can not only be integrated with your BI tools as they exist, but also with new application investments using rules engines, BPM tools, and the like. And so we take the basics of R, expand it to run multi-threaded in parallel on many architectures, and then expand its deployability and ease of use. And that's fundamentally why we exist. In order to get there, we had to make a number of changes and enhancements. This slide simply shows all of those. Revolution's off.
It looks like you may be offline again, so we're still looking at the grid.
Thank you. Yeah, I'm watching the, let me restart that again.
It looks like something may be timing out on your end.
It's kind of acting that way. We'll keep an eye on it here. I am on air again, but it hasn't updated. Interesting.
There you go.
It's back up? Okay, very good. As I
up.
said, this chart shows a number of the changes that we made to enhance the R language to support big data analytics, beginning with accelerating performance, all the way up through providing parallelized versions of major algorithms that are used in big data analytics, and eventually moving the product to run in database and some of the major EDWs and in Hadoop, both in current as an open source product called R Hadoop, and we've announced intention to move the platform into several major Hadoop distributions over the next 6 months. And let's get my screen back up here. Let's see if we can still get this to change for you. Okay, so what are the important things that we do? Above and beyond providing R with acceleration to run threaded, multi-parallel, and to chunk memory in off a disk so we're not memory limited, we've set about as well recognizing that big data is no longer something you can deal with on a single system server or workstation. And we have taken a very significant number of the typical statistics algorithms, things like generalized linear models, linear and logistic regression, k-means clustering, and on down a fairly lengthy list, refactored those algorithms so they're directly callable from our scripts, but when they execute in parallel and transparently to the R script, execute across all of the nodes in, say, a Hadoop cluster or in a clustered server such as a platform LSF Linux cluster. And this has typically a couple of orders of magnitude effect upon performance of those algorithms and enables an R programmer with nearly no change to his knowledge of R to actually embrace and act upon huge data sets very easily from within his very familiar R language. I won't go into the list of algorithms here. Many of them are fairly well understood, but they fall into 7 different categories. I would urge anyone who is interested in understanding more of what algorithms are available to get in touch with me offline or to go to the Revolution Analytics website and have a look. We provide quite a bit of detail as to what can be used from within the R language using Revolution. The effect of parallelizing these algorithms is probably best shown by this chart. We compared a generalized linear model running on a large Windows laptop with 4 cores and 8 gig of RAM. So this is a fairly mainstream laptop. The blue line is how open source R was able to perform the calculation we were after. The timing showed up, shot up pretty sharply and basically ran out of memory in the range of about 300,000 observations. And this reveals the fundamental limit of open source R. When we switch the code to call the parallelized version of the very same algorithm, uses the same parameters, it's called in the same way, the calling program doesn't have to change, the red line gives you some idea of how much performance improvement we get. In other words, shorter is better. And we stopped counting at 5 million observations, and that was on a single laptop. And this is made possible by breaking through the memory barriers. All of our algorithms do this. We provide additionally some very... Yes.
We can't see that chart, Bill. Can you
Oh
update
my.
me again?
Still
So I
having
don't-
troubles. Yes, I'm going to go short this company's stock to keep this up. I'm sure that'll have a huge impact with my portfolio. So let's let this restart. Okay, I'm showing on the air, but we haven't updated yet.
Yeah, by the way, you do have an audience view that you can check. It's sort of a good reminder to make sure that they're seeing what you're talking about.
Yeah, I'm watching the audience view on an iPad. Actually, that audience view doesn't appear to exist in the MacBook version.
Okay.
So while we wait for this to update, let me just make a couple of comments here to take this a step further. This is actually, to me, the parallelization, I think we've updated, the parallelization is actually to us the long pole under the tent. This is the work that reduces the onerous work of data science within your organization. Many people have described the data scientist as sort of a mix between a mathematician, statistician, a computer scientist who knows how to make algorithms run in parallel, and a hacker who knows how to put it all together. We take somewhere between 2 and 3 of those tasks off your plate by taking the key algorithms, refactoring them atop a platform we call DistributedR, and rebuilding those applications so all the iterations and all of the communications between nodes is accomplished in parallel, but it's accomplished completely transparently. What's showing now is our IDE. It's a fairly straightforward IDE in that it provides the types of tools that you expect to see in a good development environment, certainly a code view in the upper left, lower right object browsers, some other capabilities that are, I'm trying to get to show, type ahead and ability to look at code snippets with color coding so they're easier to understand, organizational packaging of your source code in the upper right. I mentioned that R uses a lot of packages, typically from a repository called CRAN. Those are browsable here in the lower right. We can look into the objects, look into the data objects. And finally, probably the thing that programmers like the best is a very sophisticated breakpoint-based debugger so that code can be knocked out in a very big hurry, very quickly within the tool. To take the performance discussion a little further, and not to pick on SAS, this is certainly the big dog in the analytics business, but one of our customers ran a comparison where on a 16-core Sun server they ran some model development in SAS, and they ran it as well in RevolutionR. The numbers here show some idea of the difference between the 4 different approaches. Now let me explain the 4 approaches. SAS, most of us will know much about. A little bit about a variety of products, long history in the market. In a 16-core Sun environment, their application took 5 hours to run. Some time ago, we open sourced a version of some of the R capabilities that we have today called R Hadoop or R MapReduce. This is a facility that allows people to write R code and then use something called Hadoop streaming to package that into mappers and reducers. Does not include parallel algorithms, so this is an example of where they had to build their own parallel algorithm using our logic, and it still ran a little over 10 hours for them, so it wasn't particularly fast, and this is, again, probably due to how they parallelized their algorithms. Again, the long pole under the tent. Open source R was not able to run their application because the data required with 150 million observations didn't fit in memory, but when we turned to run the very same R code in Revolution Scale R and Revolution R Enterprise on a much smaller cluster, it ran in 5 minutes versus 5 hours, comparing it to kind of the benchmark of SAS. So this gives you some idea of the types of capabilities that clustered servers bring when running R code that has been enabled to run massively parallel by Revolution R. We provide, R provides, and we continue to deliver, we're not updating here.
You still look live. You're good.
Yeah, I've changed slides and it hasn't updated.
It just shows you went offline again.
Sharing here. And we have many more comparisons like this, but looking at this chart that's currently showing, again, we notice that we reduced the size of the system from 16 nodes to 5, and achieved somewhere between a 50x and 60x performance improvement. This very same capability is what we have announced to take to the Hadoop world by the end of the year. and hopefully we'll have a successful launch of that in the Q3, Q4 timeframe. Users can get started today running on platform LSF and know that that work will be directly portable to any of the parallel environments we support. Okay, I'm trying to get updated here. We're still struggling a little bit, Tim.
Okay, no problem. If you want, we can always switch gears a little bit. You have in a couple. There you go.
Yeah, got our update.
Okay, thanks again to our audience. Thank you for bearing with us.
Yes, thank you very much. We're almost finished as well, and we're going to get to Stephen and his presentation and some Q&A. But fundamentally, R provides a lot of data visualization. What's more important is that these are actual examples of where our DeployR capability through web services provides the ability to include R analytics and the results of those analytics directly into other BI tools. The lower left example in particular is the most used BI tool in the world, and of course we all know that to be Microsoft Excel. By enabling deployment through a number of different methodologies, R can become a part of your production analytics environment. Okay, so we talked about DeployR a little bit, so I'll skip past that. Probably the most important attribute beyond performance and scale of using R in a big data environment is that, as many of you know if you follow Hadoop or you follow the clustered server business, we don't know what the future is going to hold, honestly. To be perfectly frank, who will be the best Hadoop vendor? I like the Pivotal story a lot. I think what Dave and his team have pulled together for their customers as it evolves will be an exceedingly disruptive force in the computer business. What that platform looks like after Apache releases the next major revs of Hadoop, I don't think we know for sure. And so one of the key values that we strive for at Revolution is that once our code is built, it can be ported and run without change in any of the major environments, including in database, on clusters of servers, in Hadoop clusters, or the same code on modicizes of data directly within workstations and servers. To change from one target platform to another in RevolutionR, you change 2 lines of code. You change a line that defines the compute context, and you change 1 line that defines the data source. And then, if written using RevolutionR Enterprise, the same code and the same data can run in any of these platforms. We think that is critically important in times of great change in order to achieve some protection of your investments. We are pretty successful as a company. We have a lot of major partners. We have a lot of customers, and we deliver, as we believe, and will continue to deliver, scalable performance that is portable across platforms, that brings the latest innovations in the art world to whatever platform you're on, and allows you to move between platforms fairly transparently. With that, I will stop, say thank you very much, and turn it back to our hosts.
Thanks, Bill. So we've heard Bill talk about one approach to big data science, leveraging the parallelization of R and the millions of R users. Now we're going to hear from Stephen Hillian at Alpine Data Labs, who's going to talk about the potential elements of big data science. Stephen, over to you.
Thanks very much. Thanks, Dave and Pivotal, for hosting this event. It's an honor to be here, especially alongside the Revolution guys, who I think have contributed so much to the R community. And thanks, Bill, for your presentation. So I want to take a little bit of a step back and talk about what I think are some of the essential elements to getting started with big data and data science. And maybe to take a little bit of a controversial view to say that it should be easy. I think that the general impression, I think Bill has made this point as well, is that you need this huge talent pool of programmers working in isolation. And I think increasingly people are becoming aware that it shouldn't be that difficult. And I would say the essential elements are that, first of all, you should be able to do advanced analytics. We're here talking about sort of the difference between BI and data science. And I think the first thing to emphasize is that over the last 20 years, say, most companies have gotten pretty good about producing reports and dashboards and other forms of business intelligence. It's now time for everybody to get started doing more advanced analytics, digging a little deeper into the data. And that should be possible on any data. You shouldn't have to restrict yourself to small samples, as I think we've all stated. And secondly, getting back to Bill's point about the talent pool, it should be possible for you, an organization, to build your own team of data scientists, rather than to have to go out and hire large numbers of people who understand not just what data science is used for, but how to implement it, how to code it, what the underlying mathematics and matrix operations and linear algebra and statistics do. It should be possible to leverage your own people and have them work as sort of aspirational data scientists, and have that be agile, have those teams work together, not in those silos or pockets of data science, but instead as a collaborative team. And I think the third thing to emphasize about to me, what is a core feature of a good data science backbone is that you should be able to get started immediately. You shouldn't have to go through a 6-month process of setting up infrastructure and ETL and training and so on. So I thought maybe I would sort of illustrate these points with reference to some of the work that we've been doing here at Alpine, and also in partnership with well, various partners, but in particular Pivotal. Let's start out by saying that you need lightweight, accessible tools. It should be possible to choose a very lightweight technology that allows you to get up and running very quickly, and to use the people and the data that you already have. So something that's easy to set up and point at your existing data, and that is accessible to a broader audience. So let me illustrate this. This is Alpine application, which I think embraces a paradigm of reducing the amount of code, increasing the accessibility of the application, and focusing on sort of a web-centric, sort of enterprise collaborative approach. So you see here, I thought it would be kind of fun to illustrate this on Pivotal's analytics workbench. I'm tuned into their workbench up here. This is actually the Alpine application installed on a little machine that's sitting next to the analytics workbench cluster. For those who don't know, the analytics workbench is a very large Hadoop cluster that Pivotal has donated to the community, to the Hadoop community, for testing and for experimentation and so on. So we've been using that to try out some of our algorithms. It's a lot of fun. And so a few months ago, we spent an afternoon setting up our web server on their cluster, typed in their connection parameters, and we're immediately able to start sort of browsing data that we had uploaded. Here's a few of the data sets that we've uploaded into their system. Drag those onto our workbench here. This is a Hadoop data set. Alpine works against relational databases as well as Hadoop, but this is a Hadoop one, so I need to apply some sort of structure. It looks like Alpine's done a pretty good job of guessing what the right structure should be here. And then I can start building up operations. So maybe I want to do variable reduction. For the data scientists in the room, this is really principal component analysis, but we decided that's not a very friendly term. So I might want to reduce the number of variables in this data set, and so I just connect these two up and start configuring my operator so that I can reduce the number of variables in this data set. Now I've got one here that I've got a flow here that I've already set up, and I actually ran it this morning. Here I've got a data set that I've created that I can use to run a very large, more scalable version of our application, because I'm able to leverage the Hadoop cluster that Pivotal has engaged with us. And so what we were actually able to do in this case is getting to my second point, which is not only should it be easy to set up the application and have that run immediately against my cluster without having to do a huge investment in a separate parallel structure, but it should be scalable as well. You should be able to leverage the power of your big data platforms and work with all of your data, whether it's structured or unstructured, whether it's big or small. So in this particular case, if you look at my flow here, I was actually able to run this analysis that contained decision trees, SVM classification, and naive Bayes on a data set that's the full US census. This is about 250 million rows. So I ran SVM classification to determine what income level a given individual would fall into. And I did the same thing using decision tree classifier and a naive Bayes classifier as well. And the point of doing this was that I wanted to demonstrate how easy it was just to essentially drag on these operators, as I just showed you, drag on the data sets, and build this new workflow. And if you look at the timings here from 1512 down to 1536, what's that, like 24 minutes? So about in 24 minutes, I ran a full SVM classification, decision tree, and naive Bayes on this 250 million row data set. And here you see in the log, you're seeing some progress indicators indicating that all of these things are now finished. And as a result of doing this, I've now got a classification model. I've actually got 3 different classification models that can determine your income range based on other demographics such as age or gender or number of hours worked or military status or number of years in school and so on. So this is just sort of an indication of what we think is an important feature of an analytics system, which is that it can actually leverage your existing platforms. And I think this is an important point to make. People have spent a lot of money over the last few years setting up not just Hadoop clusters, but MPP databases, traditional databases as well. And the idea that you should have to set up a separate analytics cluster in order to do your data science is, I think, something that sort of bogs a lot of data science projects down. It should be possible, as I've done here, to install against an existing cluster, use those data sets without having to export them from the cluster, and run your operations directly against those data sets in situ. So what Alpine is doing here, and I think this is becoming an increasingly common paradigm, is it's pushing the calculations down into Hadoop or into the MPP database. We support most of the major databases, and we support all of the major Hadoop distributions. So we've converted each of these operators that you see here, decision trees, SVM, naive Bayes, also others that I've got listed down here, association rules, for example, evaluation operators like ROC or confusion matrix, basic visualizations like histograms and frequency, k-means, and so on and so on. We've converted all of those to run as either complex SQL and store procedures or as MapReduce operators. And there are lots of different ways of doing this. This is the particular path that Alpine has chosen. But again, I would emphasize that I think a core component of a good analytics infrastructure is that it should scale with your data, and it shouldn't require an additional investment of infrastructure. I think the other component, as I sort of hinted at the top, is getting everybody to work together and leveraging the team that you have in a more collaborative environment. This is where we've invested in co-development of a collaborative application called Chorus, which was released by Pivotal originally. Alpine is now joining co-development of that with Greenplum. More details of that later. But what we've done is to embed the sophistication of Alpine's analytics within that collaborative application. So the idea here is that if you have a reasonably accessible, sort of light-on-code data science application, that allows you to build up a team of traditional data scientists as well as business analysts and other sort of data-savvy users who want to get their hands on some of this power, and get them working together using the power of an application like Alpine, but expose that to the broader world with a more collaborative environment, so that you've got, some people talk about this as sort of an inverted pyramid within the organization. At the tip of the inverted pyramid, you have the analysts, the business analysts, the data scientists who are digging deep into the data to yield insights. But you want to expose those to the rest of the organization, not just in a read-only way, to say, here are some interesting results, what do you guys think, but to get input as well and allow people to take part in that collaborative mode. So let me illustrate that here with the Chorus application. What I've got here is something that might look a little bit like a sort of Facebook-type page or a sort of social network-type application. It allows me to work with my data wherever it might sit. You can register databases and Hadoop clusters with Chorus, and it'll immediately go out and index the files and allow you to search them. And I'll demonstrate that in a second. You can then start doing analytics with that data, and you can set up different analytics projects. Here I've got a few that I'm a member of, and you can view the activity that's taken place recently within those workspaces as people start to analyze that data, build models, build visualizations, and so on. So just to demonstrate this, let's suppose that I'm about to do an analysis for sort of some sort of subscription analysis. Maybe I'm a telco, or maybe I'm a newspaper provider, and I want to do an analysis of my subscriptions and figure out whether they're healthy or not, and if they're not, what I can do about it. So the first thing I might do is figure out if anybody else has done this sort of analysis. And this, I think, is a key power of this collaborative application, a key feature of Chorus, is that I can use it to provide a sort of survey, a way of surveying all of the work and the data that has been collected within the organization up until now. So when I do my search, I see a bunch of things. Here's some Alpine workflows that I'll take a look at later. Here are some data sets, for example, as well as a workspace. If I click on this data set that I found, it's gone out, it's looked in my production instance, there's a development instance. If I had any Hadoop files that were relevant, these would show up here as well. If I click on this one, this is actually a table sitting in a green thumb database. I can see some basic information about here. Any comments or questions that people have written alongside this table are stored here as well. So you can think of this as sort of a self-documenting data dictionary. And I can sort of begin to do some basic exploration around here as well. I can get a brief data preview. I can start to visualize these things. Just some very simple visualization charts here. Maybe I'll look at customer status and draw a quick chart of that to get a sense of where my subscribers are at. And there's a pretty big bucket of people here who have either stopped or suspended their subscriptions. And so that might be something that I'm interested in looking at. Maybe I'm concerned about the number of canceled subscriptions and I want to perform an analysis of it. Here's where you begin to see the difference between sort of business intelligence and advanced analytics. Creating these sorts of charts is reasonably straightforward, of course. It's a sort of group by query that I've run against my database. It's helped a lot by the fact that it's an enormously powerful database, so no matter how big my customers, I'm able to get a response pretty fast. But I'm limited in the analysis that I can do here. I can really just see facts about the past, sort of facts that describe what's going on with my customer base or with my set of transactions. But I want to dig deeper and start asking why and how and what will happen type questions. So if I go back to the search that I ran on the word subscriber, I've got some data sets here, but I also see that somebody set up a project workspace called Subscriber Analytics. I'm glad that I checked because now I might have saved myself some work here. I can see that a couple of folks here have been working on a project related to analysis of subscriber data. And I can go back in time and sort of look at what people have done. There's some imports that have been set up into my sandbox, which has been set up as part of this project. Sarah and John and various other folks have created some comments here. They've uploaded and created this table subscribers, which they've started importing into. That was the table that I was just looking into. And we started adding some comments about this. And if you look further along, you'll see that I started creating some models here to analyze some of the information about my subscribers. So if I click on this particular model, this is actually an Alpine model that's exposed within Chorus. So that you don't have to be a core data scientist user to start figuring out what insights people are generating from their data science analyses. Here's a bunch of comments here that people have created as they've run and analyzed these flows. This is a fairly simple model that I've created. If I open this up, it looks like Sarah actually ran this workflow and published a result. You don't have to run these live. Chorus will now store every single result that is ever created by the Alpine application, and you can view things like decision trees and graphs and charts and so on and create comments about them. All that stuff is wrapped up in my project workspace. And so the idea is that no matter how deep you get here in terms of looking at data, running reports, creating models, analyzing those models, editing them, and so on, everybody can come together within this project workspace to get a sense of what's going on and what insights have been created. The idea really behind Chorus is to try and create a platform that data scientists can use to work together, where they have all the power of the parallelism and the sophisticated analytics of an application like Alpine. But they can do that within a context and within a conversation that everybody can take part in. So that now everybody can go in, view the output of these analyses, start asking questions, making comments, making suggestions about how we might improve these, and getting a real-time view of what the data science team is using. So really what I've tried to emphasize here is some of the core elements that I think you need as part of a platform. You want something that is easy to set up, even against the largest platforms, and that really within literally a matter of minutes, you just download this thing off the web, point at it, give it your Hadoop connection parameters or your database connection parameters, and start building models. It should be as easy as that to get going. It should nevertheless be scalable. So often with lightweight, you don't necessarily associate something that's truly scalable. What we've done here, I think, is in a sense to cheat, to say, look, the Hadoop guys and the MPP guys have already done a lot of this work for us. Let's take advantage of that rather than create an additional infrastructure that costs too much money and is too difficult to maintain. And then make sure you do that not in a separate silo, not with a single person working on the data science, but to do it within a collaborative environment that allows the whole team to take part. And I think that's really what people should start demanding in terms of their analytics infrastructure. So with that brief overview of sort of what I view as sort of the core components and the things that you should be demanding, I'll hand it back.
Thanks, Stephen. We like to say, sometimes we say that data science is a team sport, and I think Stephen has demonstrated how you can involve the different people and the different skill sets in that team sport. And so I should also point out that our own data scientists work with both of these partners' products in doing both some of our internal work and our customer engagements. At this point, Tim, I'd like to open it up for Q&A, and I'll turn it over to you.
Yeah, thank you for the presentations. Those were both really very informative. And again, thank you to our audience for your patience during some of our difficulties. While we go through the Q&A section here, I want to point out that the screen that's up right now I'll leave up during the duration, so you can contact Dave, Bill, or Stephen at any time following this event. So thank you to our audience for providing some very good questions. And the first question that I have for you today, and in terms of format, I'll leave the floor open to whoever, unless it's called out by one of our audience members if they have a specific question for either Bill or Stephen. But the first one is, it seems like you've drawn a line between advanced analytics and traditional analytics, or BI. Are they typically separate, or do they depend on each other somehow?
This is Bill. I'll take a crack at that first, and then I'm sure Stephen and Dave have some thoughts on that. But I think in many ways, they are different sports, if you will. But where we see them coming together is that what the BI world has done is created the first large data repository. The biggest repository in most corporations is the EDW. In most cases, it pales by comparison to what's being absorbed from the outside or generated from sensors. But the overlap is at the data source and at the point of deployment. We see a lot of users wanting analytics created by an analytics team, but deployed out through desktops that are already running in the organization, and this is typically through BI tools. So they come back together at the user in some cases. But in the middle, I think it's all a pretty separate work with pretty separate disciplines. I don't know what thoughts the other presenters have.
Okay. Thank you, Bill.
Yeah, this is Steve. I think I'd agree. I think that they've tended to attract a different group of users, and they have sort of different techniques and sort of technologies, and that one's a little bit more retrospective, and one's a little bit more forward-looking. In my mind, the definition of advanced analytics, or the definition of traditional analytics or business intelligence is about sort of performing descriptive statistics on quantities of data in order to understand sort of past behavior. And advanced analytics is about applying statistical and machine learning techniques in order to either build predictive models and predict the future, or at the least to understand sort of inferred facts about the past from your data. So it's a greater level of inference and productivity. And I think those are two very different things. But I do think, I do think they sort of lean on each other quite a lot. It's like we often think of, the BI engines as being like the question generators, and something like Alpine or Revolution as being like the answer machines. That's a little bit of a simplification, but I think it's often true that you'll look at a set of charts and reports, and those will just bring up further questions, some of which can be answered within BI as you drill down and so on, but some of which require sort of more advanced techniques. So I think that they lean on each other in that way, in the sense that BI leads to more advanced analytics because it leads to questions. And I think the direction goes, the arrow goes in the other direction as well, in the sense that once you've created additional learned facts from your data by doing more advanced analytics, whether that's a customer propensity score for buying, or some sort of credit score, or risk analysis, or identifying a customer as part of a given customer segment, you're essentially creating new columns in your data. You're creating inferred dimensions or inferred facts that can then be consumed by those business intelligence applications. I think that's another reason why it's important to have the analysis close to the data, because if you can build up these extra dimensions and push them right back into your database or into your cluster, then that means that the BI applications can take advantage of them.
Very good. Thank you both for those answers. Another audience question is, which is more important, the ability to write code to do analysis, or two, to understand the key business questions and what data content will provide the best answers?
Maybe I'll go forward first on this one. I mean, I think that it's important to write code because without the code, you can't do these analyses. I think the question is who should be writing the code. And in my mind, I think Bill made this point as well, in my mind, you shouldn't have to write a lot of code in order to implement a regression on Hadoop. Or you shouldn't have to write a lot of code that joins two large data sets together and have to worry about how that's going to scale. People like me should worry about things like that. And the data science should focus on the execution of those functions at that higher level, whether that's through an interface like R or through a visual interface like Alpine. Leave Revolution and Alpine to worry about implementation of these algorithms and focus more on sort of asking the questions and getting the answers.
Very good. Okay. Bill?
I agree. I make a further comment that, you know, the interesting thing is when you take PhD level statistics of math and you try and bring that to the daily user, I think the harder question is to know when the answer might not be right. That's probably the toughest challenge, and I'm not a data scientist. Stephen is a card-carrying, serious data scientist. Maybe he'd have some comments on this, but you know, throwing algorithms together isn't what we're trying to do here. What we're trying to do is to help people understand, and sometimes that winds up with a tiered infrastructure, a tiered labor system. And I actually think this is one of the places that the BI world was instructive. There is not a single layer of labor in the implementation of BI systems today. There are probably as many as 5 layers. There's an expert in getting the data, that's the ETL guy. There's an expert in managing the data, he's got the warehouse. There's an expert in building things like templates, if you use MicroStrategy, or universes if you use Business Object. And then there is a class of person who is there to make sure it's most easily accessible, and those tend to be the report builder, the screen builder, the mobile app deployment types. I think we're going to wind up in the same game, and I think we're going to use the same teams to do it at some point and at some level. So don't plan on a singular homogeneous workforce. I think that's a fallacy that has cropped up 100 times. It's why we still have probably 30 active programming languages in the world, ranging from Excel to Visual Basic to R to Java to Python to Ruby on Rails. I don't think that's going to go away.
Okay. So this next question, I think, dovetails nicely with that topic, and the question is for both Revolution and Alpine, and the question is, do you guys provide an API to use the product in the back end of analysis products designed for users without specific data science knowledge? So.
Yeah, I'll give a quick answer to that. Yeah, we have an API that allows you to run these workflows with different parameters and so on. So that's just a REST API, and you can pass those in, and then you can also export them as a Java executable, so you can run it in sort of standalone mode.
Okay.
Roughly the same answer for Revolution. I mentioned the DeployR product, which is one way to bring answers to your people, and the DeployR facility utilizes web services as a method. And I think actually Stephen touched on something that deploying to the UI is only one way to use the results of advanced analytics. The scoring of information and the addition of information to fact tables or to CRM systems that is analytically derived is every bit as popular, if not more popular, than popping stuff directly onto desktops when it comes to the productionalization aspect of what we do. I think most users aren't there yet, but I think all of us know we're going to get there.
Okay. In the spirit of ending on time, I'm going to let this be the last question. We have about a minute left, and let's see. This is which environment is better for analytics, Hadoop or relational databases? You might need to make your answers rather brief.
The answer's both.
That's possible.
How's that for brief?
I'm sorry?
The answer is both, at least from our perspective. How's that for brief?
That's perfect. Stephen?
Yeah, I would say in some ways Hadoop has the advantage in terms of being able to explore and deal with different data sets and not have to worry too much about getting your stuff into relational form, and it has this massive scalability. But people shouldn't forget about the relational databases either, because they still have the advantage of speed, and there's an awful lot of them out there, so we can't ignore them.
Okay. So thank you for some great questions, audience, and Stephen and Bill for some really good answers. For those of you that did ask questions that were not answered today, please rest assured that all the questions are being sent to Dave, Bill, and Stephen, and they will respond to you at a later date. I just have a couple of quick announcements. Please mark your calendars for July 18th, our next Data Science Central webinar on analytics, NoSQL, and visualization, which is sponsored by MarkLogic. As I also mentioned earlier, this webinar is being taped and will be available on demand by tomorrow and can be viewed by going to the homepage of Data Science Central and going to the video section on the lower right-hand side of the page. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, Pivotal and Dave Menninger for their sponsorship and insight in today's topic, and our panelists for their insight as well. My name is Tim Madison. I'm very pleased to have been your host today, and we look forward to seeing you again on July 18th. Good day.
The organizer has ended the session, and this call will be disconnected. Goodbye.